Thread Overview, Part 1. What is it? In this set of Silicon Labs training videos, we'll get an overview of the new Thread networking stack, including what it is, how it is developed, and its key advantages and features. First, we'll explain what Thread is and where it came from. Thread is a protocol stack designed for embedded wireless networking with emphasis on low power consumption, scalability, and robustness. Since Thread is designed primarily for device-to-device communication within the so-called Internet of Things, or IoT, data rates are relatively low in comparison to technologies like Wi-Fi or Bluetooth, where streaming video or audio data is common. However, like Wi-Fi and Bluetooth, Thread is only designed to be a networking stack without attempting to define the application protocols that can run on top of it. Generally speaking, any IP-friendly application layer protocol can be implemented on top of Thread, although some are more practical within the bandwidth constraints of the radios involved. The main goal of Thread is to provide Internet Protocol connectivity among embedded devices in a local network, as well as seamlessly communicate with other IPv6-based devices residing on the global Internet. What distinguishes Thread from previous wireless IP stack efforts is its focus on minimal memory and networking overhead, yielding a solution that can fit well within the flash and RAM constraints of today's devices and provide low latency and high battery life. To maximize its global acceptance and build upon other successful protocols, the Thread stack was architected around globally recognized and publicly available international standards, such as IEEE 802.15.4 and DTLS. All layers of the stack utilize protocols described in IEEE documents or IETF RFCs, with draft RFCs proposed in some cases to provide low-power 15.4 friendly optimizations of existing standards. Work on Thread began in 2014 among founding members of the Thread Group, the consortium that designs, governs, and promotes the Thread networking stack. These founders, including Silicon Labs, Freescale, ARM, Assa Abloy, Samsung, Big Ass Fans, and Nest, now part of Google, developed the Thread 1.0 standard around existing protocols and new RFCs, and applied lessons learned over years of serving the embedded device market. The Thread Group has now grown to well over 150 members, and sponsorship-level members now include Tyco, Somfy, and other well-known device manufacturers. Now let's look at the market requirements that drove the creation of the Thread networking standard. Thread's target market, though certainly not its only applicable one, is primarily the connected home use case because that market's well established and is a space where other wireless technologies like ZigBee and Z-Wave have traditionally focused. First, all devices must be directly addressable from within the home area network or HAN itself, as well as from other internet-connected devices like personal computers, smartphones, and tablets. Thread serves this need by ensuring that all devices have a unique IP address that can be used for local or global communication to and from that device, just like any other internet-connected device. Second, the network construction must be very straightforward so that the networks are simple enough for the average retail consumer to install. This means minimizing protocol-specific knowledge required to set up the system, such as order of commissioning, route construction and maintenance, and special procedures for certain node types. Installation must also be achieved without the need for specialized commissioning tools while still maintaining security and access control. Thread meets these objectives by leveraging existing user interfaces and security protocols on a smartphone or tablet to handle commissioning. The network should be scalable between a few devices and a couple hundred devices, since the size and complexity of a home and its network can vary widely among consumers. This requires an appropriate balance of sufficient routing capability to ensure connectivity without overwhelming the network with route maintenance and network density. Thread is designed to handle over 200 devices in a single network, and much larger networks can be achieved with careful planning. Latency in network communication must be minimized, especially for common user interactions where delays of more than 100 milliseconds may be noticeable in the final output. Thread efficiently compresses and optimizes packet formats to allow most messages to fit into a single packet without the overhead of a connection setup and teardown, and routing latency is minimized by pre-calculating all routes in advance. Just as a Wi-Fi home network may require several access points for coverage and redundancy, so too must the IoT home network be able to support multiple access points to pass traffic between the Thread-enabled devices and the rest of the wide area network or global internet. Thread networks can exist with one, multiple, or even zero of these access points, or border routers as they're known in Thread. In the age of smartphones and internet appliances, customers often expect to be able to control embedded devices with this existing infrastructure without a need for dedicated controller devices. Communication with the Thread network is handled natively by existing internet routing and addressing protocols, meaning that manual translation between protocols is not required. And finally, embedded home networks must allow for battery-powered devices like sensors, alarms, and door locks to operate efficiently for multiple years on traditional power supplies and maintain connection with their networks with minimal amounts of latency. Thread serves this goal by leveraging a low-power IEEE 802.15.4 MAC layer in conjunction with efficient packet formats and low-latency communication protocols. By satisfying the previously mentioned market requirements, Thread is positioned well as a networking stack for the residential or light commercial space, and could be practically applied to a variety of different IoT devices, including line-powered nodes like a wireless access point, a light bulb, or a smart plug. Devices with a mix of power sources such as smoke detectors, window shades, or thermostats, and devices relying solely on a battery power like door locks, biometric sensors, and door window contact sensors. Communication in Thread can be between embedded devices in the same HAN, or inbound or outbound between those HAN devices and another connected device within the home's wide area network, like a smartphone tethered to the local Wi-Fi access point, or on the global internet, like a server farm in a cloud network. Intra-network communication can span multiple hops via router-capable Thread devices, and communication outside the network can be achieved with the use of one or more border routers, devices with multiple IP-capable networking interfaces that can funnel traffic in or out of the local Thread network based on the IP6 address of the destination. Using this model, a given HAN device can be controlled within the home or within another HAN device with the user's local Wi-Fi network, or globally from a cloud-based management service. Of course, there are other wireless networking technologies intended for sensing and control in the HAN, so what makes Thread unique? Well, in addition to being based on existing international standards, Thread is most notable for being IP-based, meaning it uses Internet protocols common to other Internet-connected devices. So there's no longer a need for vendor-specific gateways to handle the proprietary translation of non-IP-based packets and addresses to those suitable for routing to the Internet at large, and vice versa. In an age where most systems pass data to and from the Internet for the control and storage reasons, seamless connectivity to the Internet is vital. Thread is flexible in that the network device types are managed by the stack at runtime based on the capabilities that the user provides in the firmware. So, installers and users don't have to nominate one special device to manage all the others or understand the significance of certain nodes. Thread is robust in that there's no central point of failure in regards to routing, both within the Thread network and in the communication with the outside world. Thread offers an optimal balance of strong security and access control versus the complexity of commissioning new or returning devices. Commissioning is kept simple from the user or installer point of view, even though the underlying technology is quite sophisticated. Thread is optimized for low power operation, making it practical for devices that sleep or duty cycle to save power. And lastly, Thread's technical requirements are such that it can run on today's wireless networking SoCs, including Silicon Labs' EM358X and EM359X IC families. And it will be API compatible and over-the-air compatible with the next generation of wireless platforms from Silicon Labs. In part 2 of the Thread overview, we'll look at these key advantages in more detail.